you remember the last question? I said, find the cosine if it's in a specific quadrant. Now look at this. Here's this, and it says actually solve for this. Well, what am I solving for? Well, of course, I'm solving for theta, right? And I want to know something. Wait a second. Wait a second. This guy, in fact, is negative. Uh-oh. Well, where is sine negative? I don't know. Add sugar to coffee. Ah! Sine is positive here. Sine is positive here, but it could be negative here or negative here. Oh, okay. What do I do with that now? You're going to have to do this question twice. Sorry, you're going to have to figure out for one's going out here and for the second one going out here. That's all you got to do. Okay, well, wait a second. How do I go about doing this? Well, let me show you something really, really cool. You know that sine is part of SOHCAHTOA, right? You know it's part of SOHCAHTOA, and you know that sine is opposite, so that must make this opposite, that must make this hypotenuse. Oh, wow, did I get a lot of information here? Now, remember, you're dealing with reference angles, which means you always deal with the x-axis. So again, look at this. There's the reference angle. You're dealing with the x-axis. Where's the reference angle? Your reference angle is here, and your reference angle is there. Neat. Okay. Hypotenuse then is 2. Well, that's easy. That means that's 2, and the length of this one is 2 there as well, because it's opposite of the 90 degrees. But this opposite is negative 1. Well, remember, eyeballs, that's staring at the opposite. That's got to be negative 1, and look at that. Eyeballs staring at the opposite. That's negative 1, which makes sense because after all, that's going down, right? And so is that one. Now, my question then is this. What is that angle? What is this angle right here? That's what I'm after. And if you think about this for a second, think about this. You can actually use special triangles for this. Think about it. If you remember the special triangles, this one here, 45, 45, 45 was 1, 1, and root 2. Okay? That's not this because I'm dealing with 1s and 2s. But if you remember this special triangle, which is 1, 2, root 3, you're in fact dealing with, guess what? There's 60 degrees there. There's 30 degrees there. Opposite over hypotenuse. Oh my goodness, that angle's 30 degrees. That means this reference angle right here is actually 30 degrees here and 30 degrees here. No calculator necessary. No, I know what you're thinking. You're probably saying, oh, gee, could I possibly use a calculator here? Yes, you could. Just don't use the negative sign, okay? Opposite over hypotenuse, right? The sine of an angle. Opposite 1 over hypotenuse 2, find what that angle is. Remember, you had to inverse sine both sides to find out what that angle is. Okay, so if you want, you can do that right now. Inverse sine, right? 1 over 2. And look, it'll actually give you 30 degrees. I didn't need a calculator to tell me that because I have this beautiful thing called a special triangle that helps us figure out all of it without a calculator. So, that being 30 degrees, that being 30 degrees. But my question is, what is the actual angle in standard form then? Well, that's easy. Standard form starts here, goes to here. So look, it's up to 180 degrees plus an extra 30. So 180 plus the 30 works out to be, that's 210 degrees. So that angle could be either 210 degrees or, check this out, could go all the way around to here, almost 360, right? Subtract the 30 degrees from it, which is your reference angle, gives you 330 degrees. So this particular question, theta has 2 answers. It has 210 degrees as an answer and 330 degrees as your other answer. Pretty cool.